For this lesson, we're going to be taking a look at a review of linear relationships, which is one of the key topics from your grade 9 math course, and it's going to really be an important part of the grade 10 math course as well. So, we talked about this when we were talking about just algebraic expressions, and when we talk about variables, a variable is a placeholder for a value. Sometimes that placeholder represents a single very specific value, and that's usually the solution, let's say if we're doing an equation or something along those lines. But other times, the placeholder can actually be a placeholder for many values. And in this case, you can see I have x taking on the values 0, 1, and 2. So the expression 2x minus 1 is actually going to change its value depending on what the values of x are. So when I start off with x equals 0, then my expression 2x minus 1, well, it's no longer going to be x, it's actually going to be 2 times 0 minus 1. And then we go ahead and evaluate that. 2 times 0 is simply 0, minus 1 gives us an answer of negative 1. I can then say, okay, well, what about evaluating 2x minus 1 when x is equal to 1? 2, but instead of times x, now in the place of x, I'm going to put the value 1. Minus 1 is equal to 2 times 1 is 2, subtract 1 is 1. And I do the same thing here for x equals 2. So that gives me 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. So depending on which value of x I make use of, my value for the expression 2x minus 1 is going to take on a range of values. And that was the values I came up with there, negative 1, 1, and 3. Now if we decide that we want to examine how does the expression 2x minus 1, how does it change as x changes, that's called the relationship. What is the relationship between x and the expression 2x minus 1? When we graph something, the way we graph something is typically we will have an x-axis and a y-axis. So the way that we explore this relationship is we have our x, and on the y-axis, that's where we're going to put the values 2x minus 1. We don't normally write it that way though. What we're going to do is we're going to say, okay, up here on the y-axis is going to be the expression 2x minus 1. Y-axis is equal to 2x minus 1, or it simply becomes the equation y equals 2x minus 1. Every one of these x values has a corresponding y value, so that's what those become. So those are the y values. So 0, negative 1 is an xy coordinate, 1, 1, 2, 3. And we can graph those. So if I move ahead, I take a look. So we start with our x values. Here you can see I've got negative 2, negative 1, 0, 1, and 2. When you graph things, you really I want to see 5 points, 5 good points. Then I know that you've covered your bases, that you've done your arithmetic correctly, and things all make sense. So we've got y equals 2x minus 1. So when x equals negative 2, I have 2 multiplied by negative 2 minus 1. And what is that equal to? 2 times negative 2 is negative 4. So wherever there was an x, I replaced that with a negative 2. So instead of 2x, I have 2 times negative 2. That's negative 4. Negative 4 minus 1 is negative 5. 2 times negative 1 minus 1 is equal to 2 times negative 1 is negative 2, minus 1 is negative 3. 2 times 0 minus 1 is equal to 2 times 0 is 0, minus 1 is simply negative 1. 2 times 1 minus 1. 2 times 1 is 2, minus 1 is 1. And 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. Some of these were numbers that we actually came up with. These ones, these 3, were the ones that we did on the previous page. Now, each of these represents an x and a y value. We've got our x values here, negative 2, negative 1, 0, 1, and 2, and we have our y values here. And the y values are these values that we've come up with. -5, -3, -1, 1, and 3. So let's turn these into some points on our graph. So I'm going to choose a scale. So I'll make that 1, make that 2, make that 3, -1, -2, -3. Same thing vertically, 1, 2, 3, -1, -2, -3. You can see that on my scale, the x and y spacing is equal. Each of them is 2 of these small grids or 1 of the large grid lines. That's my x-axis. That's my y-axis. So that's a proportional scale. That means the x and y axes, they take up the same amount of room. Not all scales will be that way, but that's what I've chosen here. Next thing I'm going to do, I'm going to switch colors here. My first point is -2, -5. So the x value is -2, so I go over here to -2. The y value is down here at -5. I didn't label it. I'm going to label it in just a moment. So there is my point. So that is the point, -2, -5. And I'm just going to go ahead and finish my scale here. So there's -4, there's -5. And I'm going to have to go as high. I think I'm good with the rest of the scale that I've got here. So let's go to my next point. X equals -1, y equals -3. X equals -1, y equals -3. So there's my next point. -1, -3. 0, -1. X equals 0, y equals -1. 0, -1. X equals 1, y equals 1. X equals 1, y equals 1. So that's simply the point 1, 1. And finally, x equals 2, y equals 3. X equals 2, and then I go up to y equals 3. X equals 2, y equals 3. And you can see, just from the graph I've got here, these dots line up quite nicely. They form a straight line. I don't have a very good color to choose here, but that's okay. I'm just going to choose black, and I'm going to draw a straight line through those, and I want to make sure that I put an arrow on the end and an arrow on the end to indicate that this line continues in both directions. So not only is it these 5 points, but it's all the points in between along this line, and it extends indefinitely up to the right and indefinitely down to the left. This is a linear relation. The relationship between x and y, when you graph it, forms a line. That's what we mean by linear relation. Okay, and I say that right here. A linear relationship occurs when both variables are linear. When we looked at that graphically, that meant we ended up with a straight line. Another way to talk about this being linear is this idea that both variables have an exponent of 1. So if we take a look at, and I'm just going to write it over here, if I write just the variable x, what is the exponent of this variable x? Whenever we have, there are certain times when we don't write numbers, and one of those times is, how many x's do I have here? I have 1 x, and what is the exponent of this x? It's also a 1. So when there's no exponent, the exponent that is understood to be there is a 1. So that means that this is y to the power 1, this is x to the power 1. This is an x to the 1, this is a y to the 1, this is an x to the 1, this is a y to the 1. So as you can see, all of these are to the exponent 1, which means our x's and our y's are all what we call linear. So that's the linear relationship, the idea of an exponent of 1. How I write it is irrelevant. Here I have all of my x's and y's are to the exponent 1. Now, it's actually a little bit more subtle than that, and I realize I could do a better job of explaining that. What it actually means, what I should say, it's not just when both variables are linear with an exponent of 1, it's when all terms have a maximum exponent of 1. And so, for example, if I had x multiplied by y, well, in this case, the x has an exponent of 1 and the y has an exponent of 1. So there's something that we call the order of a term. So this term is actually order 2. This is an order 2 term because the x is to the exponent 1, the y is to the exponent 1. To figure out the order of the entire term, I have to add up those. So this is an order 2 term. So if we ever saw something with an x multiplied by y, that would no longer be a linear relationship. So we'll talk about that in a little bit more detail later on in the course. We'll see relationships that have an xy term in them, and then we'll know that that's not linear. So how do we graph a linear relationship? Table of values. That's what we did on the previous page. Here's a graph using a table of values. We can also use the y-intercept and x-intercept, and that's something you talked about in grade 9. I'm going to remind you about that now. And we can also make use of the y-intercept and the slope. Again, that's something we did in the grade 9 class. We're also going to look at it here. When we graph these things, if we're using multiple points, we only need 2 points to graph a straight line. It's a good idea to do a third point, and as I said on the previous page, when you're doing some sort of table of values, I want you to do 5 points, just to make sure. You want to make sure these things are consistent. If I had done this and a couple of points were not on a straight line, or if it was obvious that things were not making a straight line, I want to know that. I don't want to place all my faith in just 2 points. Okay, so using the intercepts, that was the second option. Table of values is number 1. Number 2, using the intercepts. The x-intercept is a point where our line crosses the x-axis. That's why it's named that way. And similarly, the y-intercept is the point where the line crosses the y-axis. Now, if you think about that, maybe I'll draw just a quick little rough graph here, and I'll put a line on it. So here's the x-axis, and here's the y-axis. So the x-intercept is where the point crosses the x-axis. So that would be the x-intercept right there. Well, if that's the x-intercept, what we want to know what is the x value that goes for that, but because this is the x-axis, we ask ourselves, well, what's the y value that goes to that? How high is this point above or below the x-axis? And if you look at that, you would say, well, it's not above and it's not below the x-axis. What it actually is, it's 0 units above and it's 0 units below. So the way we find the x-intercept is we want to find the point that's 0 units above or below. That's the same thing as saying it's the point where y is equal to 0. To find the y-intercept, which is right here, it's on the y-axis. So how far to the right or how far to the left is this point? Well, it's not to the right and it's not to the left. It's actually right on the y-axis. So to find the y-intercept, we set x equal to 0. And if we have some sort of linear equation, we can substitute in y equals 0. That will tell us this x value. We can substitute x equals 0, and we can find this y value. So let's go ahead and do that. So I've got 2x. I'm just going to go ahead and rewrite this. 2x minus y minus 1 equals 0. Being careful to copy it down correctly. I want to set the y equal to 0. That's going to give me the x-intercept. So I rewrite 2x minus, but instead of y, I'm going to set 0 there. I'm putting in some extra steps here just to make it really clear. Minus 1 equals 0. So 2x minus 0, that doesn't change anything. So we've got 2x minus 0 minus 1 equals 0. Now I'm going to take that negative 1, I'm going to move it over to the right side. The way I do that is I add 1 to both sides. And when I do that, I end up with 2x all by itself, and 0 plus 1 is 1. And now to get the x by itself, I'm going to divide both sides by 2, divide by 2. The reason I divided by 2 is 2 divided by 2 is equal to 1. That leaves me just 1x there and 1 over 2, we're going to leave that in fraction form, and we end up with our x-intercept is equal to 1/2. We do the same procedure to find the y-intercept, except for this time we're going to set x equal to 0. So I start with my equation 2x minus y minus 1 equals 0. But instead of x, I'm going to replace that with the value 0. So I end up with 2 times 0 minus y minus 1 equals 0. 2 times 0 is 0, so this just becomes negative y minus 1 equals 0. Now this is a negative y. It makes a lot of sense for me to actually turn that into a positive y, and the way I'll do that is I'll add y to both sides. So this is an alternate. If you've looked at the other tutorial on solving equations, there's a couple of ways that you can do this. So if I add y to both sides, then this negative y and this positive y, they actually cancel each other out. When you say cancel, that means that they turn into 0. There's nothing left. So all I've got left there is a negative 1, and 0 plus y is equal to y. And you can see negative 1 equals y is the same thing as saying y equals negative 1. We normally like to write it in this second form because normally convention says we write our variables on the left and our constants on the right. So there's my x-intercept, and this one is my y-intercept. So I can just use those two. Now I mentioned to you before, you want to have more than 2 points to draw your straight line. But when you're using the intercept method, all you're going to get are 2 points. So these are the 2 points we would use to do our graph. We would start at x equals 1/2. Now obviously what I've got drawn here doesn't correspond. But if we were doing this as a graph, we would put a point at, actually let me make sure I'm really clear about that. We would put a point at x equals 1/2, and what was the y value that goes along with this? It's y equals 0. We would put this one at the x value is 0, and the y value is 1. So here are 2 points. We could graph those, and that would give us our answer, or our graph. And so you can see I've got a grid here. And if we recall, so we ended up with our x-intercept at x equals, let me make that a little clearer. My x-intercept is equal to 1/2. My y-intercept was equal to 1. I'm just going to go back and double check, make sure I've got... No, I'm sorry, see, I made a mistake there. You have to be careful even when you're transcribing things. Negative 1 is the y-intercept. So let's go ahead to our page, and so that's negative 1. And those are points. We can write those as points as well. We could have written this as the point x equals 1/2, y equals 0. We could have written this as the point 0, negative 1. So let's go ahead and put a scale on our graph. So I'm going to say 1, 2, 3, negative 1, negative 2, negative 3, 1, 2, 3, negative 1, negative 2, negative 3. That's my x, and that's my y. So my first point is at x equals 1/2, y equals 0. X equals 1/2, halfway between 0 and 1. So there's my first point. That's my x-intercept. My other point is at 0, negative 1. 0, negative 1. There's my y-intercept. And I've only got 2 points, but that's what I have to work with here. So now I'm going to draw a line that goes between those 2 points. And in this case, I'm going to extend the other corner like that. And then I will finish up by just drawing in my arrows on the end of this line to show that it extends past. And if you were to look back at the graph we did using a table of values, even just flipping between those pages, I think you can see it's the same line. So we ended up with the same straight line, even though we came up with this line 2 different ways. Now we have to look at slope. Slope is such an important concept. It was really quite important in the grade 9 course. You might argue even more so as you move forward. So there are a number of ways to talk about slope. Generally, the first definition you learn for slope is rise over run. But there's a couple of more algebraic ways to represent slope as well. We can represent slope. Sometimes people remember slope as delta. I'm going to change the color for that. Delta y over delta x. Some people just remember that. It just kind of rolls with it. It just sticks in their memory. But the deltas, what do those actually mean? Delta is actually a Greek character, and the mathematical definition for delta means difference. So delta y actually means the difference in y values. The second y value minus the first y value. Delta x is the second x value minus the first x value. Make sure when you write these as subscripts. You write them as smaller numbers below the x, below the y. If you were to write them above, if you were to do something like this and this, you're writing exponents. Whereas we want to use that 2 and that 1 to distinguish between this is the second x variable, this is the first x variable. When we use slope to help us graph, we still need to know the y-intercept. We're going to use the y-intercept as our starting point, and then we're going to build our graph using this idea of slope. And it really, when you're doing this on a graph, you can use these concepts, delta y over delta x, y2 minus y1, x2 minus x1, but you can also just make use of this idea of rise over run. So I'm going to go with the simplest interpretation. I'll show you that. If we want the y-intercept to be our starting point, then it would be nice if our equation was written in a way that gives us that starting point. And so a linear equation, this is the way that most people think of a linear equation, has two forms, has two key pieces of information in this form. The m here, well, that is the slope that we just talked about, and the b is the y-intercept. There are some alternate forms of this that you might see just based on convention, or it's just based on what people need to do. So sometimes you'll see y equals mx plus k. So sometimes people use the letter k for the intercept. Sometimes you'll see y equals ax plus b. So some conventions make use of the letter a for slope. Some conventions make use of the letter k for the intercept. You just have to roll with that. If you see it happening, you need to be comfortable and confident enough with your mathematics that you recognize that this is a linear equation. Here's the y, that's the vertical axis, that is the dependent variable, and then you've got something multiplied by the x, and then a constant, that's your y-intercept. Okay, so let's take a look at the equation I've been given here, y equals 2x minus 1. So picking out the pieces from there, the easy one here, the negative 1, that means my y-intercept is equal to negative 1. Another way of thinking of the y-intercept as negative 1 means the x-coordinate is 0 and the y-coordinate is negative 1. Then let's take a look at the other piece that we're going to get out of this. That is that the slope, which I'm going to use as the letter m, is equal to 2. But the slope is the same as saying rise over run is equal to 2, or delta y over delta x is equal to 2. All of those things are true based on that value. So once again, label my axes. I've got a 1, 2, 3 on my x, negative 1, negative 2, negative 3, 1, 2, 3 on my y, negative 1, negative 2, negative 3. And my point, start off with that point, 0, negative 1. X equals 0, which is right along here. This is the y-axis. And I go down, negative 1. So there's a point. And now I actually use my idea of slope in order to build. You know what? There's one other thing I'm going to add here. Slope is equal to 2. That's equal to rise over run. But rise over run is a ratio, something over something. So it's actually something you want to keep in mind is whenever you see a whole number like this, if your slope is not a fraction, just to remind you, you can always write that as something over 1, because 2 divided by 1 is simply 2. But now we've got this idea of rise over run. So now we start here on my y-intercept, and my run is 1. So that run is +1. That means I go to the right, +1, and then my rise is +2. So that means go up by 2. 1, 2. And there is another point. And I can repeat this. To the right by 1, up by 2, and there's another point. It works the other way as well. Another way that you could look at this is that my rise over run is 2 over 1, but that's also the same as -2 over -1. We wouldn't normally represent it this way, but when we think about rise over run, it actually makes some sense. I can go to the right by 1 and up by 2, or I can go -1, which would mean go to the left by 1, but when I go to the left by 1, I have to go down by 2. And to the left by 1, overshot by a little bit there, and down by 2. So you can build using this concept of slope, rise over run. You can build going to the right, either up or down. In this case, we went up, or going to the left, up or down. In this case, we had to go down. And finally, I go ahead and draw my straight line. I'm going to use a nice thick straight line in this case, just because I've got all those kind of ladder shapes in place. Nice thick straight line all the way through. Really exaggerated. And you can see that straight line, just going to go back to one graph. That's the same straight line between all of them. Okay? So we've got 3 different ways to find the picture, the graph that goes along with a linear relationship. Linear relationship, we've got linear terms. Everything is only order 1, so an order 2 term wouldn't work. And we can graph it 3 ways. Table of values is always your kind of first line of defense. If you can't remember to do anything else, table of values will work. Then we can also look at the x-intercept and y-intercept. We can also look at the y-intercept and slope.